Right, and we are now live-ish. I'm just doing a couple of last prod set things that have got the wrong picture. But yeah, we are now live everywhere that we can be, or at least everywhere I care about. We could be more, but 4's enough. So, welcome back to Cyber Cafe Sci. We are still around. We took a break of a few weeks just to catch our breath and work out where to go forward. So I've got a couple of exciting announcements and some less exciting but still essential. One is we are going a bit more sporadic with our schedule, so we'll still be trying to do regular Thursdays as much as we can, but we're only going to aim for a couple of months unless we can get more speakers in, simply because with time differences and so on, it's quite hard to get speakers together. So if you know anyone who'd like to speak, do please prod them and send them our way, because we'd love to have them on. But on that note, we've got a very exciting one coming up towards the end of October, which will be our first non-English Cyber Cafe Sci. So we're going to have a session entirely in Portuguese, host and everything. We've found a host to replace me for that one. And we are going fully international, which I'm very excited about. I don't know if anyone else is, but I think it's a wonderful thing to do, and it's a really good sign that there is actually some international reach. And yes, Cafe Scientific is a global movement. So again, welcome back, and I'm just quickly going to introduce our speaker this time, who is Chris Bohr, related to me, you may have guessed from the name, and will be speaking on the Da Vinci Codex and a particular journey of discovery. And I think a lot of it comes down to a ladder, if I remember correctly. Is that right? Yeah, all comes down to a ladder. So Chris, if you want to come on and you can do the quick introduction for Cafe Sci, because I'm in desperate need of a glass of water.
You have a glass of something else, James. Right, I'm just going to share my video first before I talk. Here, and we think, I want to check that you can all see that. How do I know you can see it? Someone's going to have to tell me.
Yeah, we can see it.
Yeah, okay, that's
Popped
good.
Up everywhere.
All right, brilliant. Okay, I'm standing in for a speaker who had to cancel at the last minute because she's not very well, so we wish her well. But I'd want to take this opportunity to say that all our speakers at Cafe Sci always have been, and I hope always will be, volunteers who do it for the love of it. And we're incredibly grateful to them. If there's any problem, like you have to drop out, that's absolutely fine, because people like me can step in at the last minute. And I admit, this is a talk I've given before, but it's one that I chose because I think it's extremely relevant. It's the first talk I ever gave at a Cafe Sci. It's very relevant to the venue that we then used eventually for our own live Cafe Sci in my hometown of Woking. And it's also one that talks about a journey that, as James said, was quite special to me, but also I think illustrates what Cafe Sci is about in some way, which is partly to do with a more eclectic, more all-encompassing view of science and scientists and those who can be involved and will be involved. If anyone wants to speak at a Cafe Sci, by the way, it's enormous fun. And a lot of it for me is when I get the privilege of speaking, I almost enjoy that more than I enjoy listening to other people speak, but that might be just me. The first Cafe Sci talk I ever gave was in Kingston. It was a university Cafe Sci, and it was a special type of event where they didn't have just one speaker. We had a number of us, and it was called storytelling. You had to put together a short story, a narrative about something loosely scientific and yourself, and then present that. And I went along to it. And one of the special things about it was that one of the other presenters was Helen Sharman, who was Britain's first astronaut. And I'm an astronaut junkie. I worship these people. The chance of actually meeting a real live astronaut made me want to kneel at her feet and ask for her autograph. But unfortunately, Helen gave a talk about the first female astronaut, who was a Russian, and in that talk made it abundantly clear that having been in space once was certainly not something that defined her as a person. So being an astronaut was something she did, but it was not who she was. And so I have never since dared to tell Helen that I worship the ground she walks on because she's been into space. And I didn't ask her for an autograph, even though I came to know her reasonably well after that, which was a pleasure in itself. People are not always defined by the role that we see for them. But the talk I gave was something that meant quite a lot to me, because some years before, I had volunteered at our local art gallery, which is called the Lightbox. And you'll see later on that the Lightbox likes to think it's more than a gallery. And in fact, it actually is. And the Lightbox eventually hosted our live Cafe Sci that I set up in Woking. And that's been running for nearly 7 years and has now morphed into this brilliant cyber cafe sci, which is online, which James put all the work into creating and supporting and providing the technology for. And it's allowed us to continue during the times of lockdown and COVID, but also it's been marvelous because it's let us reach out to speakers in other countries, in other time zones, and also to audiences more globally. And part of that is that the talks are streamed on other services and then recorded as well, so people can watch them at different times. And it's been very special for me because I've very much enjoyed setting up our live Cafe Sci, but to see it sort of sprout out into the beginnings of a more inclusive virtual movement is actually quite special. When I volunteered at the Lightbox, they were lucky enough to host an exhibition of Leonardo's machines. That's Leonardo da Vinci's machines. It was his engineering marvels. And I've been someone who's learned a lot about Leonardo on painting because it was relevant to my work in digital video and digital image processing. But I was also interested in his particular engineering. And this centers around my job at the Lightbox as a volunteer, which was to guard an original, genuine Leonardo Codex. Well, that's not actually quite how they put it. My job was to enhance the visitor experience, and in order to do so, I had a walkie-talkie and a special buzzer with a big red button which I was to press to bring security if any of the visitors tried to enhance their experience by damaging or stealing this incredibly valuable Leonardo Codex. And here you can see the famous iconic cinematic moment when Tom Hanks rushes through the Lightbox gallery in desperate haste to catch the last bit of my talk on the Da Vinci Codex. Leonardo's machines are machines that he designed, some of which he made, and most of which he didn't. So Leonardo was a very eclectic designer. He was a Renaissance person who was an artist, an observer of things, an engineer, a maker of things, and a thinker of great ideas. And the picture here is of the Leonardo machines exhibition in the Museum of Leonardo in Florence, where they've reconstructed some of the machines, and these are things that have been brought over for us to see. If you get to Florence, which is well worth doing, you can go in the interactive Leonardo machines gallery where you can have a go on them and see if some of them work. And actually, a surprising number of them do. This one's my favorite. This one comes up later. This is a flying machine. I don't think the wings are big enough on this one to support a man, but you see the man is strapped into this flying machine in all kinds of ways. His arms are strapped to the wings, and then he's got pedals on his feet, and every part of his body is being used in order to provide energy to the flying machine. But I digress. My job was to guard an original Leonardo Codex. It was Forster Codex 2, and the Forster Codex 2 is kept at the Victorian Albert Museum in London. It is extraordinarily valuable, and it is also amazingly delicate and must not be exposed to light. So it's allowed out of the vaults in the V&A Museum only once every 2 years for a maximum period of 2 weeks. And during that time, it must be kept in special red low light conditions and in a special climate conditioned glass case. So in the gallery, the darkened light with the Codex illuminated under its special red glow, I had plenty of time to look at Leonardo's work. And it's very interesting because these codexes are collections of Leonardo's writings. He was a prolific note taker. He would note down everything that he saw. So it was almost like squirrel, but he didn't do it just like I did. When he saw a squirrel, he would try to note down how it moved. He'd write down what he thought about it, what might be possibly its motivation, what might be the mechanics of its movement. He would try to sketch it in different positions of movement. He would probably try to catch it, butcher it, cut it open and draw its inside. So he was an extraordinary person with observational science. And that's the thing that I really enjoy about some science, the idea that you sometimes just look at things and think about them. You don't always have to propose a hypothesis, test it, and write that authoritative scientific paper. But the Codex didn't look like this one that I show you, because paper or vellum was extraordinarily valuable. So people used to just use any scrap they had available. Some of them were large pieces, almost A1 size, folded up. Some of them were just tiny scraps about the size of a page of A6 or even smaller. And in order to keep these together, Leonardo was renowned for tying them up in a bundle and then attaching that bundle to his belt. And the Forster Codex is quite a nice one because it's quite small. And you can imagine this tied to his belt, but it wasn't like that originally, because when Leonardo died, his papers were scattered all over the place. And his student, Melzi, tried to gather as many of them as he could into one place, but was defeated mainly by Leonardo's family, who sold them or sold bits of them. So people would pay money for a Leonardo signature, and they would take one of his notes and tear his signature off it and sell that, and then tear the other one into 4 pieces and sell each individual drawing. So the papers became scattered all over the place, and the vast majority of them are lost. I think there are still something like 9,000 pages of Leonardo writings, and that's reckoned to be only about 10% at most of his total output. And of course, it's completely muddled. So the codexes are sort of random. You see a drawing of a war machine and then a horse, and then speculation about the flow of water, and then there's a windmill and things. People have tried to reconstruct them, and the best book on that is actually Leonardo on Painting, which was the one collection of papers that the student Melzi managed to keep together and put into some kind of order. And it's a beautiful thing, because if you read it, it all makes complete sense, and I'll show you some extracts from it later on. And it is really the guiding principles behind realist art, but also photography, digital video nowadays. And that's how I first encountered Leonardo. But the Forster Codex was not open on the page that I show you here. And also in that room was an interactive terminal. And on the interactive terminal, you could sort of virtually flip through, and you can do this if you go to the website. Just look up Leonardo Codex, and you'll find you can peruse your way through all the Leonardo codices that have been made public by people. So you can flip from page to page. These are the 3 Forster Codexes. They're named after the person who bought them. So that's a classic way in which we recognize our wealth-oriented society. We name things after the people who paid for them, not the people who actually did them. And these ones are all nicely bound in a sort of leatherish cover here. Many of the codexes are owned by one man, and that man is Bill Gates, and he is responsible for buying those codexes for the purpose of making them publicly available for free. So here you're looking at rather posh terminals. In the Lightbox, we didn't quite have this rather nice wood on it, but these are terminals where you can see the codexes, and he has the original codex there also. What I became struck by was that I was looking at a device that was for recording every thought and then going back and seeing.
You're just being asked something quickly.
Oh, yeah.
Why are they called codexes? What does the word codex actually mean?
Well, a codex means like a collection. So a codex is a collection of writings. So it refers to the fact that they're collected together and bound. It's funny because it sounds like they're in code, doesn't it? That's like we all think of Dan Brown and the Leonardo Code, but they're not in code. Well, they are. I'll come to that. But they are codexes because they are a collection of things bound together. So it occurred to me that I was looking at something that existed before smartphones. People like me carry our smartphone on a holster attached to our belt. Leonardo was carrying his notepad on a cord attached to his belt. He was recording everything he saw. So do I. I photograph things, I make notes, I record my appointments. I put reminders to myself. So in some of Leonardo's notebooks, for example, it says 3 apples, 2 tomatoes and an egg. So he's obviously recording his shopping list in it. And the atmosphere in a darkened gallery in a museum when you're on your own for quite long periods is quite odd because it's sort of mysterious and pensive and you think quite a lot. And so I did. And in looking at the codex, I realized I was looking into a moment in Leonardo's life. It was almost as if I was scrolling through his smartphone. I'd looked at a particular page where he'd thought of something and wrote it down. So it was like a snapshot into the person's actual thinking, which is quite extraordinary if you think about it. Now, the codexes have all sorts of things in them. I was concerned with the machines. So most of the things I'm going to show you are machines rather than artistic representations. But I think you can see here how extraordinary his mechanical skills were. And in fact, also, you can see the detail of his drawings. These look like machines that were actually made. So over here on the left, I can see a design for something. But here I see something that looks actually real. So that gives me the idea that these were actually constructed. They were more than just an idea. They weren't just a hasty sketch. And it's quite interesting that every detail of it is drawn. So including, do you see here, he's got the bolts that are holding it together or the dowels that are holding that together. Every piece of it is drawn in exquisite detail. His mind was all over the place. But it was all over the place in an amazingly focused way. So these are all devices for lifting water. These are war machines. So part of his money came from saying that he could help you to make machines to win a war. I can construct you a machine that can throw giant explosive devices that will demolish the walls of the strongest castle. This one here is particularly interesting. It's an absolutely humongous crossbow. This down here is a person. You can see the size of it. And there's a TV program where they reconstruct this and have enormous trouble because the construction of it is hard because the mechanical properties of wood will not sustain the forces that are exerted on it. But if you look here, you see this stripy pattern in the wood. What they found was that he'd worked out that if you made a wooden beam by carefully gluing together pieces of wood, like a sort of plywood, you could actually make something that could just about sustain the force. And most of the TV filming is this thing smashing itself into smithereens, which is also kind of cool. This one down here at the bottom I love. It's recognizably a speedboat, isn't it? And there's a film where they have Leonardo da Vinci and he's walking on water in sort of boats that he's made for his feet. And he's this jovial, weird character who's always off on some mad quest. And that's how I like to actually think of him. And here is another war machine with these Boadicea-like scything devices in it. He didn't only design things, though. He was also the inventor of marketing, because many of these war machines he had never made, nor could they actually be made. They were inventions of his mind that he could make, but he didn't mention that. So in his proposals to the Duke of Sforza, he would say, I have constructed machines of such devastating potential that your armies will be undefeatable. And this was his way of saying, employ me and then I can do this, which is, well, I suppose it's a kind of marketing, isn't it? He wasn't entirely an honest person in that respect, but he was sort of over-promising and sometimes under-delivering, which I think we can all recognize as something that we can do. These machines being in the gallery when I was guarding them, you could go around and look at them. Many of them were flying machines, and there were also some of the war machines in there. This one's particularly interesting because this is Leonardo's bicycle. Leonardo invented the bicycle, and we had this in the entrance foyer at the Lightbox. And when I was not guarding the Codex, enhancing the visitor experience of people who came to see the Codex, I was a guide to the Leonardo exhibition. And being me, I was an entertaining guide because a lot of the stuff I told, I sort of made up. Well, it was plausible. It was interesting and maybe had some basis in fact here. But the bicycle was perfect because, of course, Leonardo never invented a bicycle, but they'd made one that looked like it. And so as we came in, I would say, here's Leonardo's bicycle. And people would go, well, that's amazing. We could invent the bicycle, but he actually didn't. And this one down here, of course, is a Leonardo Codex or a code machine. You'll recognize that because that comes out of Dan Brown's the Da Vinci Code. And what you do is you set up a code along here. And if you try to open this without the correct code, it breaks a vial of acid, which dissolves the vellum inside and so destroys the message. So it's a secure device. It's an early example of Renaissance cryptography. And that's just as much nonsense as the bicycle, because actually Leonardo never invented that. It was a dramatic device for a film, but it was an entertaining film in its way. Some things were constructed and were so futuristic that it's hard to recognize precisely what they were. This is a self-driving car. It is driven by clockwork. You bend some of the beams as you would winding up a clock, and then the clockwork ticks through ratchets in such a way that it drives the wheels of this chariot, and you can set cogs and stops in such a way that the chariot does not describe a straight course, but wends its way in a sort of curved, sinuous course that's quite attractive. This was actually constructed. It is the first example, I think, of a self-driving car. It's about 20 feet across in the real design. And it was designed as a launching platform for fireworks. And it was used once. That's amazing, isn't it? So you can quite see why someone like Leonardo would gain a reputation as a magician, if you like, because he was doing this. This thing would advance onto the stage and wander across the arena and flash off fireworks and explosions and things in smoke in all directions. It was almost literary smoke and mirrors, but it shows the extraordinary way in which some people were very much in advance of their time and designing engineering. But look at the detail in this diagram here. Every part of it is drawn so that you can reconstruct it. That's how people nowadays have been able to reconstruct Leonardo's machines, because he gave you the detail of how they worked. Now, sometimes he didn't. Sometimes there's a detail in there that means it won't work. And I believe, and so do others, that that was an early example of intellectual property protection. It's a bit like, if you're old enough, you remember log tables, tables of logarithms that were printed in a book. And you would look up the numbers and then look across the columns to the logarithm. And of course, because they were just numbers, they weren't copyrightable. You can't copyright a set of numbers. But what they would do is they would build in a deliberate mistake, so that if you just copied their book, you could prove that they had done so because they would have copied your mistake. Leonardo went a little bit further. He would build in something that couldn't work, so that if anyone found his bits of vellum and tried to manufacture his machine, they couldn't make it without him to actually do it, which is also kind of cool. He also had a method of writing that may have been code or may have simply been accidental. He was left-handed and he wrote mirror writing. So his writing is all back to front, and you can read it in a mirror, or if you get used to mirror writing, you can actually read it straight through. He also wrote in Old Italian, which makes it more difficult for people like me to read it, but you can get translations of this. Something strikes me about the way that he's drawing, and that is this. Many of the scientists I most admire were very proficient at drawing very precisely machines. They were anchored very concretely in the real world. So they weren't theorizing. If I were going to draw a machine like this, I'd probably draw a couple of wheels like this, and then say cogs or something. I would draw a more abstract, that looks funny, doesn't it? It's about as good as my drawings are. I would draw a more abstract, simplified form of this. I wouldn't draw every cog. I certainly wouldn't draw the shadows or the background in such detail. But some scientists do, and I think it illustrates something in their thinking. Here is Niels Bohr on the left and Einstein. Niels Bohr and Einstein pictured at the Copenhagen debates. Many of you will know that the Copenhagen interpretation of quantum mechanics was the subject of furious discussion at that time. Niels Bohr believed that there was nothing behind the mathematics. Only the mathematics of quantum mechanics existed, and what you saw was all you could imagine, or indeed was all there was. Einstein believed there must be something underneath the quantum mechanical calculations. He accepted that we could never see it, but he believed that it must actually be there. And the Copenhagen debates were a series of debates between the two of them where they discussed this or argued it out, furious arguments. And at one point, Einstein won the argument. That it turns around the concept of uncertainty. You can't measure speed and position at the same time. You can't measure energy and time. You can't measure mass at a precise moment in time. So when you measure two quantities that are linked by quantum mechanics, you can never measure both of them absolutely precisely. And Einstein proposed what he called a Gedanken experiment. It's a thought experiment here. So this is entirely theoretical. These were both totally theoretical physicists. Einstein's experiment in his mind was this. You have a box. Inside the box is a single photon of light. That's a particle of light. And that particle of light has an energy and therefore a mass. So here is the box. Inside this box is a light particle. I have a shutter on the box here, which is operated by a clock and a mechanism. The clock opens the shutter at a precise moment in time. Now I know for sure the time. The photon exits through the shutter, and I know precisely when it exited. And here I have a spring and a scale. And because the photon exits the box loses a little energy, therefore loses a little mass, and therefore moves upwards. And by measuring on this scale, I can measure the mass that was lost. So I now have the time and the mass at precisely and exactly the same moment. This is very famous because it completely floored Niels Bohr. And there is actually a picture of Einstein after this debate striding along with his long coat flapping, and Niels Bohr with his arm reached out, almost imploring him. And you can almost hear him saying, Dr. Einstein, we must talk about this more. We can't. Yeah, Niels Bohr stayed up all night, as you would, the whole interpretation of quantum mechanics being demolished. And he drew this box here. So this box encapsulates Einstein's thought experiment. And what Niels Bohr argued, correctly as it turned out, is this, that yes, you can release the shutter at a precise moment in time, and yes, you can measure using this scale the mass of the box, but the spring has sufficient uncertainty to precisely match the uncertainty that is required. More than that, any conceivable method of measuring mass must necessarily have the uncertainty if it's to operate within a certain time. This hinges entirely on a rigorous interpretation of the genuine physics and the mechanistic physics of it, but I'm not going to go there. That was where Copenhagen interpretation came from. That was the final defeat of Einstein and his acceptance of the fact that there is nothing below the hood in quantum mechanics. But what I'm interested in is this. Niels Bohr didn't sketch out box like I would, and shutter like I would, and clock like I would. He drew the clock. He drew the mechanism that drives the clock, the weight that's pulling it down. The spring is a real spring. I would draw spring like that. And so I think would most modern scientists. But he is anchored so much in the real mechanical physical world, even though he's purely a theoretical physicist, that he cannot help himself from drawing it absolutely and precisely, just indeed as Leonardo does here. So the art of drawing is a key component in terms of rendering reality here. This is not a thought experiment, it's genuine. Some of what Leonardo did is very recognizable to us. And this is interesting. This is a sort of geometric drawing, and he's showing projections here. Now, in this case, Leonardo's writing goes from right to left and is back to front. So this is mirror writing. And these letters here, which look a bit odd, are all back to front. So I'm now going to show you this reflected in a mirror. Do you see what he's doing here? A, B, C. Yeah. In much of his writing on these geometric interpretations, he talks about it in this way. So he says, imagine the angle subtended by the line ABC. He talks about the angle dropping a perpendicular. In class, we used to go ding when the teacher dropped a perpendicular. The language in which he talks about geometry is precisely the language that is now used in schools. We talk about the line ABC, the included angle A, and so did he. I don't know if he invented that, but it's interesting to me that that has persisted over all these hundreds of years. And that brings me to something which James mentioned, the man on a ladder. This is the page in the Leonardo Codex that was open. It is a drawing of a man on a ladder. And in writing, it says here, calculate the force exerted on the ladder at the points B and C due to the weight of the man standing on the ladder at point A. That's really quite intriguing because it's sort of schoolmarmish, isn't it? And remember, I was watching this, looking at this for hours because it's too dark to read anything else than the Codex. So I had nothing else to do sometimes. If there were no visitors for me to enhance their visiting experience, all I could do was look at the Codex, this magnificent book that represented work from one of the greatest geniuses of Renaissance times, and stare at this picture. And it seemed familiar. Not just because it's like, you know, the line BC, the man on the ladder, but something else was eerily familiar about it. And so that's really the crux of this story and where I will eventually end up. But before that, let's digress, because it's well known that one of Leonardo's total obsessions was birds and flight. He was obsessed by it. He wanted to fly. He wanted to make machines that would allow man to fly. He studied birds. He drew birds. He dissected birds. He looked at their musculature, at their skeletons, at the way their feathers went. He drew them in all kinds of positions in flight. He said this was because he remembered as a baby a kite. That's not an artificial kite, but a kite bird descending and sitting on his stomach and then kissing him on the lips, which would be a remarkable thing. And that had inspired his lifelong passion for flight. And many of the machines in the Lightbox Gallery then were flying machines. Now, these are interesting. This one is a sort of ornithopter here. It's got all kinds of gears and things, and you do it to paddle these wire arms up and down. That's why it's called an ornithopter, because it sort of flaps its wings at you. There's also a helicopter. There was a parachute, and a parachute's amazing because, again, people have made this parachute and someone dropped themselves out of an aeroplane using this parachute, which is made of wood covered in linen. And it apparently, he thought, possibly slowed his fall. Well, it might have accelerated it because it was so heavy. Luckily, he had another parachute, so he was able to parachute out of the parachute before it crashed heavily into the ground and smashed itself, and if he'd been attached, him, to smithereens. But it was a parachute, and he had kind of worked that out. And here we've got a design for the flying machine that I showed you. It's not sufficient, though, in science just to draw something. You want to experiment, you test it. So Leonardo thinks, or he doesn't think, he wants to check the idea that a man has enough strength to fly. He knew perfectly well that a bird's muscle to weight ratio was massively higher than a man's. He knew they were incredibly strong for their incredibly light weight. He was trying to build a machine that would give a man an advantage by giving him wings, if you like. And if you flap your wings, can you lift yourself off the ground? And this, to me, is empirical science writ large. This is a perfect example of an experimental physicist or engineer. How can I test that? Well, this machine was in the Lightbox and it was hilarious. Unfortunately, I wasn't allowed to operate it because it would have been really funny to do so, but it's fascinating. This is a wing. Question: can a man flap that wing with sufficient strength to lift himself off the ground? Now, I don't want to go in yet into building the actual flying machine, but can it be done? Well, what he did was this. He made a sort of hinge mechanism here and the big wing. And then he said, and these are his notes, find the strongest, heaviest man you can and have him thrash the lever to the ground with all his might. And if that effort lifts the machine from the ground with the man with it, then the man is strong enough to fly. That's actually really cool. I totally love that. It reminds me of my granddaughter, who's, I think she's 10. I always forget if she's 9 or 10. She would do something like that because she'd come to me and she'd say, Granddad, if I made this big wing and got a strong man to thrash it to the ground, maybe he would fly. And if he did, then I'd be able to fly too. And that, to me, is sort of the combination of engineering, science and empiricism that I totally love.
So just quickly, first of all, she's 10, not 9.
Thank you.
She'd be sure to remind you as well.
She would.
Secondly, just quickly going back to the parachute, would weight have accelerated the fall of the, not the fall as in the person who jumped out of the plane with that parachute, although foolishness might be debatable there, but the fall of acceleration downwards?
No, it wouldn't really, because it did exert a resistance. So the man falling in free fall would certainly go faster than the parachute. And that's in fact what he had to do. He had to streamline himself and point downwards to get himself out from under it as it was falling. But it was sort of jokingly said that the parachute made things worse. And it was unfortunate because you had above you, a considerable weight of wood and linen, which was going to smash into you when you hit the ground. But a lot of Leonardo's things, he didn't have quite the same respect for health and safety as we do. He was a slightly reckless person, and that was interesting also about him. So Leonardo was commissioned to build a giant equestrian monument for the Duke of Sforza. And he conceived the idea of the monument being a horse rearing up on its hind legs. And brass is not strong enough to support that. The leverage was such that the metal would crack. The normal way of doing that is to put a support here So you'd have the horse rearing up and touching a rock. But Leonardo didn't want it to touch a rock because he wanted it to actually rear up. And it was a humongous amount of brass. It's actually not possible. You can't do it without some kind of reinforcing frame, but he didn't know that. And he took the commission to build this monument. And it took an enormous amount of bronze from the Duke of Sforza in order to do it. And here you see some of the designs for the casts for this thing and so on, and then the designs for how it might be. Maybe it could stand on the ground. But interestingly, in order to build this, because it was so big, he needed a large building. And so he persuaded the Duke of Sforza to gift him a building the size of an aircraft hangar. And he divided it. He put in a false ceiling to the ground floor. And above that, he built flying machines on the Duke of Sforza's money, in the Duke of Sforza's time, and tried them out. So they were gliders and kites and things like that. So he was so obsessed with flight that he was testing these things in this massive aircraft hangar. Eventually, the Duke of Sforza lost patience, took all the bronze, went to war with someone and used it and melted it down to make weapons anyway. And it was the subject of a bitter rivalry between Leonardo da Vinci and Michelangelo. They loathed each other, by the way. Michelangelo, like the statue of David, it's a very muscular statue. And Leonardo famously said, "No man ever stands with all his muscles tensed in the manner of a Michelangelo." But Leonardo da Vinci had never met a modern bodybuilder or model, so he was maybe wrong in that sense. And they had furious arguments in the street. And Michelangelo would riposte with a reference to Leonardo's horse that was never built and never could be. But the question I'm interested here is the flying. So the horse, it seems, was really not a pretext for, but it's like you're commissioned to write a paper or a report. And while you're doing it, you go off on something else. And then you find, oh, I'm not doing that. I'm doing something else. Oh, but I've got this to do. So you've got a project that really you're working on, but you know you should be doing something else. I mean, that happens. Maybe my audience, it's never happened to them, but it certainly happened to me sometimes. Did Leonardo ever fly? Well, it is thought not, but there are two pieces of evidence that I think suggest that he did, or maybe not fly, but at least attempt to fly. One is a statement from a lawyer who grew up in the valley where Leonardo had been brought up and which had high cliffs and was a perfect place from which to launch a glider to test a flying machine. And he refers to Leonardo da Vinci, he who tried to fly and crashed. So that's evidence of a sort. And the second thing is that in this design back here, quite a long way back, oh, I can't find it. Excuse me, stop me when I see the flying machine. I did show you to you, didn't I? Ah, here we are. In this design for the flying machine here, the man is strapped in to this flying machine in order to harness every part of his musculature. So his arms are tied into the wings, his hands and wrists can also be used, even his fingers. His legs are used, his hips can flex, and there is a band around his head so that by moving his head, so every muscle that the man has is used to power this machine. And in his description of this, Leonardo writes, to power this machine, you must strap yourself in as tightly as you can, but not too tight on the head because it really hurts when you crash. And I think that's as much evidence as I need to say that he did indeed sail off a cliff and crash into the ground and tried out flight. Here's a plan of a city that he drew. And actually, this is not evidence of being able to fly, even though it's an absolutely perfect bird's eye view, because it's well known that he did this by dead reckoning, by pacing, noting the change in direction, the angle through which you turned, and then going on. It's an absolutely remarkable achievement to produce a perfect map of a city that looks as though you were flying over it. So he didn't really need to fly, because he could sort of fly in his imagination. And here is a larger scale, an aerial view of a river valley and lakes, which is really quite extraordinary. So why did I become familiar with Leonardo da Vinci? It was through painting. This is the treatise on painting. It's the only extant collection of Leonardo's works that's arranged in some kind of coherent order and is more or less contemporaneous. So as I said, when he died, his family grabbed his papers and flogged them off to the highest bidder and tore them up and scattered them all over. But his student Melzi tried to capture as many as he could, and he gathered together Leonardo's writings on painting. And Leonardo was not an organized writer, so he hadn't even written them in some kind of order, let alone he'd intended to write a book. You know, he was one of those people who was like, I'm going to write a book, but he didn't ever actually organize it. He just wrote loads and loads and loads of fragments. But you can begin to see here how beautifully illustrated this is. And for me, this is ray tracing. So this is the shadows cast by and on a sphere by different light sources. This is what you do when you're designing CGI, when you're trying to create an artificial scene in a game or a movie, or just in rendering something scientifically. Now it's routine because we do it with massively powerful computers, but this is the working out of how that works. He's seeing how the light rays fall on the surface, how they illuminate most brightly those surfaces on which they fall perpendicularly, and less brightly those on which they fall at an oblique angle. And he's noting that the shadows gradually progress as you go through it. So this is one of the things which is the ray tracing and shading, which he was famous for in painting, but is actually still precisely how we do it now and guided me in all my work on digital video and image processing. And here is light on a profile. So here we're looking at how the light falls on the profile of a man. It's a very ugly man. But then Leonardo was famous for liking ugly people, because he would write in his notebook something like, saw a really ugly man at the market today, make a point of going down there in the early morning light when the light is better and paint him. So he was already, you know, fascinated by the grotesque and the odd. And he was also a good enough photographer to say, yeah, the important thing about photography is to go down when the light conditions are exactly right. So again, you see how good this is. And this is what guides our perception. And if I read Leonardo on painting, I'm almost reading a modern textbook on digital photography, digital image rendering, video. It's all to do with how we see things, what is actually there, but also what we perceive to be there as we go through it. Perspective. Very controversial at the moment, perspective. You know, was it invented in the Renaissance or not? But here is a beautiful drawing of perspective, which is what we use to render on televisions, for example. So they may be viewed from the side or from beneath, keystoning and things like that, but also modifying the scene so that it looks right from the point of view that you are looking at it. It doesn't work anymore, because nowadays nobody looks at a television from the angle from which they were designed to be viewed. They put them at a position that looks pretty in terms of the place on the room. So we're always looking up at them and seeing people with big feet and small heads. But ideally, the perspective is designed precisely to suit what you're actually doing. And Leonardo's codexes were really a notepad. So they were a notepad on which he was recording everything and anything that occurred to him. So this is an amazing battle scene here for the Battle of Anghiari. Here you will recognize a drawing for the Last Supper. That's the subject of the Dan Brown, you know, is someone about to try and stab Peter has someone deliberately knocked the glass over? But Leonardo writes about that. And not only does he draw this, but he also annotates it. So he says, somebody has knocked over a glass. Someone holds a knife. And he describes it in words to himself as well. The Last Supper is an interesting instance of how genius and engineering can still meet their nemesis, because the Last Supper is a fresco. It's painted on plaster, and the normal way of doing a fresco is to paint it quite quickly on the plaster before it all dries out. But Leonardo had a brilliant new method of doing that allowed him to paint it and then go back days later or weeks later and add to it. And this was his undoing. Firstly, because his method didn't last, so the whole thing sort of fell to pieces, which is why it's now heavily protected. But also because he didn't finish. Because he could go back and keep messing around with it, he always did. He'd always go back there and be up a ladder. And the person who commissioned it was absolutely furious and wrote, he's always painting bits on it. I want it finished. I don't want it perfect. But that was the price of genius. Here we've got a study of the proportions of the human body for sculpting, but also for drawing. And here we've got looking at the skeletal system, the heart. He was not averse to cutting open dead people and dissecting them and drawing everything that he saw. And these are some of my favorites, because I also am obsessed by water and the way it swirls and the way the waves make. So these are water pouring into a basin, and here is water passing an obstacle. So these are observations annotated of what he actually sees without yet having an aim to it. It's simply saying, when water passes an obstacle, it looks like this. So you're like collecting all of your data, your evidence, without a hypothesis or a theory of how it works. You're building up something that is going to become. And to me, science is partly like that, or should be. The model of science is, I come up with a hypothesis, and then I propose a way of testing it, and it is confirmed or not. And sometimes it's like that, but most often it's not really. Usually you've got an agenda. Somebody says, can you design this? And you go, oh, I don't know. I'll have to work out if you can do that. And you make a hypothesis and test it out and see if it works. But more often, I think, certainly for people like me, you look at something and you think, wow, that's interesting. And you keep looking at it and you don't have a purpose to it. You're not even really trying to understand it. You just sort of think it's interesting. And that's why I said that Leonardo is a perfect model for Café Sci, because Café Sci is not your standard presentation of science. It's not an authoritative lecture. Here I am delivering my words of wisdom to you. I am teaching you something that I already know. Nor is it the academic paper, aims, methods, results, conclusion, my authoritative take on this matter. It's an exploration. It's somebody saying, I saw that and that was really interesting. I mean, somebody today just said something like they dropped a coffee bean on the floor and they thought, wow, I wonder what the journey was of that coffee bean to just end up dropped on the floor and not go through the coffee grinder. So to me, that says there's someone out there who studies the journeys of coffee beans and knows about that, because we're in a world with lots of scientists, and that's a beautiful kind of science. And I think Café Sci is all about that. If it's interesting, there's a narrative to it, there's a speculation to it. It doesn't need to be a polished, completed work. And in fact, I'm much more interested in something that's like a thought in progress than I am in something that's already done and dusted and in a textbook and gathering dust on the shelves. So my assertion is that Leonardo's Codex is a smartphone, and that when I was looking at the Codex, I was hacking Leonardo's smartphone. I was looking into a moment in time when a Renaissance genius was thinking about something and coming up with something. And everything in there is recorded, just as we now do. We record what we're doing, we archive it, we keep it so that we can refer to it later on. And there's a reason we do that, because we keep a logbook. So if you're an engineer, a scientist, or inventing something, you want evidence of what you did. This is a notebook. This is the evidence that supports or backs up this patent, because this proves that this was the first time it was published. This is evidence of prior art. It's evidence that this was actually done by these people. So if I come along and try and patent something, the challenge to that is, well, you weren't the first person to invent that. Motorola invented that first. No, I didn't. I'm Nokia. I invented it. And hence these huge battles emerge. And so good engineers and good scientists are always taught to keep a logbook, usually a written logbook, handwritten in many cases, and then archive it. I used to do a lot of work with Philips, and Philips had a system of the blue book. They would keep the blue book. Every engineer was issued a blue book. They would fill it up. When it was filled up, they would check it in. It went to the archivist, and it was there in case of a challenge, or presumably in case something went disastrously wrong. And some poor bloke had to go and root through the archives and find out the paper trail that showed them where the mistake had originally been made. When I used to teach occasionally at a university, I would make my students keep a logbook. There was only a logbook for the project that they were undertaking. It's quite funny, really, because they're resistant to it. So I would give them this task, and I'd say, you get 10% of the marks for the logbook. But when I first did it, I was so inexperienced, I didn't realize that that wasn't sufficient. I realized that they would get 10% just for having a logbook. So they could have had anything labeled logbook and got their 10% of the marks. And so the next year I intended to change it, but I forgot. And so I jokingly said to them, by the way, if you just produce anything with logbook written on it, you'll get 10% of the marks. And I thought that was very funny. And do you know what? Nearly half of them didn't produce a logbook. But the logbooks had a purpose. They were so I could see what they'd done and who had done what at what time. So because it was group work, I was looking for evidence of what went on, and those logbooks were archived. And it's interesting because when I was retired from that university, the first I knew of it, as I tried to log on to my account, I was only a part-time lecturer anyway. I tried to log on to my account knowing my course had been discontinued because it had run for 9 years and was really out of date now. And my account had been deleted. And along with it, every single record of everything I had ever done at the university and the records of all the work my students had done. And so I think it's probably worthwhile, dear university who shall not be named, to recognize that if you were a Renaissance artist, you would keep that stuff. And our cavalier attitude to archives and records may be responsible for future generations totally losing track of what went on. Who knows if one of my students invented something amazing that future generations might want to know about? Well, they won't now because it's gone and deleted. Anyway, enough of that. The man on a ladder. This is what started me off on this entire talk because it was an interesting thing. It's very schoolmarmish. What is the find the force exerted on the ends of the ladder at the points B and C because of the weight of the man standing on the ladder at point A. Notice that Leonardo has drawn a perfectly beautiful ladder and a man. He's not a stick figure like I would draw. It's an actual man standing on ladder. And here is him setting out the potential problem. Underneath here is a later statement that has been added. So it's in a different color ink, and he's obviously come back to this at some point. And what he says is, drop a perpendicular from the man to the line BC. Ding is what we said when the teacher said, drop a perpendicular. We thought we were so funny. Ding, we drop a perpendicular. And that's the first step in the solution to this problem. And so what we realize here is that in hacking Leonardo's smartphone, we're not just looking at a record of what he did, we're looking into a moment in time when he was thinking. Here, he poses a problem. He thinks, and at some later time, we see him start on the solution to this problem. This is the ladder problem. This is something that every student learns in GCSE. That's in school, teenage physics, the ladder problem. Find the force exerted on the feet of the ladder by the man standing on the ladder. Notice that this is not a Leonardo here. Ladder problem is something that bores students to tears. It bored me to tears when I was at school because you just learnt it. You were learning about moments, and moments are the solution to this problem. And moments start by dropping a perpendicular from the man to the floor. But the point here is that once, nobody knew that. Once, it wasn't something you learnt at school. Once, people had to think about it and think it through. And here, in this one dramatic moment, we are looking at Renaissance genius Leonardo da Vinci starting on the solution to a problem that we now all learn at school. Once, we didn't know everything. Once, things like this were really exciting. And by looking at the Leonardo Codex, you see that incredible moment in time happening almost before our eyes. Thank you.
Thank you. Right, let's take your share screen away.
Oh, you can do that for me. That's good.
Yes, I can.
It's great.
Right.
So good having someone completely familiar with all this technology. It's brilliant.
Okay. Again, welcome back to all of our attendees. You know the normal drill now, the quick clicking the raise and lower hands. We've not had many questions in, but I think what we'll do is our normal thing. So we'll go off the air in just a second.
I just want to congratulate George and Barbara for drawing a picture of themselves in their participant's name. That's amazing. It is a picture of yourselves, isn't it? That's really clever.
Of one of them, I think.
Is it just one of them? I thought it was two people snuggled.
Yeah. No, I think it's just one.